So now we're going to use the factory tools to lock the engine up and set the cam timing as per the factory spec. So I've had the degree wheel out, hopefully it won't move. I need to put it back in again. Okay, the crank locking tool is this. Factory tool goes in the end of the crank, locks it up, and this screw here goes into this screw here. I should have turned the engine over to top dead centre. And this tool locks the engine in one position only, which is the horizontal top dead centre firing, which is the master position for all camshaft timing on all the Ducati engines. So we pop the tool in, goes in here, and then we'll slide into the crank. Do the screw up, tighten the crank, and then we move it around till we get this in position here. And so when it goes in, it's happy. We'll screw in, it doesn't want to screw in at the moment. There we go. So that's screwed in. There's really not any movement, so that's tight. And that now is the crankshaft locked, the top dead centre, horizontal firing. What we do now is we undo the cam pulley. And this is pretty much the part of this that I don't like. When you undo these half screws here of the pulleys, it lets the inside of the pulley move relative to the teeth, so the camshaft can move independent of the teeth on the pulley. But when you undo these screws to allow it to happen, the pulley, because it's got belt tension on it, will cock outwards and the belt tension drops. And the idea is at the factory, you undo these screws so the whole lot moves independently, then you set the belt tension, then you tighten these screws up, then you check the cam timing. The problem I have with that is that when you tighten the screws up, the belt tension will increase, and then the belt tension's no longer right. And if you think it's right when the pulley's loose, it might be tight enough to cause you issues when the pulley half is tight again. So I don't do it that way. I don't ever back these screws off unless I'm doing the cam timing like we're going to do now. Degree wheel in the engine. This method sets the cams where the factory wants them to be, but I would not set belt tension while I'm doing this. I would set the belt tension, and I checked it previously and the belts are right. So now I'm going to crack these screws, the camshaft will move around, or the pulley will move, and then we can tighten it all up, then check the cam timing again. So just crack these screws. I haven't got the camshaft locking tool in yet, because I don't know if the camshaft's in the right spot. I guess I can try. We'll put it in the back and see if it screws in. It appears it has. Crack these off and see if it changes at all. Okay, so they're all loose now. And that's screwed in tight. If you want to see how much the camshaft moves, we'll wind the tool out again, wind the locking tool out. With the camshaft, that's the range of movement you have in the slots. So it's a fair amount. And so I'll put the tool back in, and it shouldn't go in. There, it's stopped. And so I'll move the cam around a little bit, and then the tool somewhere will happily screw in. There we go. So now you can see it's still moving a little bit, and again, this is one of the problems you have. It's not 100% locked in position, so which way are you going to go? I like to be advanced, so I'll put it on the advanced end. And I must say it's actually quite a lot of difference in that slot. That's a few degrees of cam timing right there. So some of the locking tools are better than this, but this is one of the reasons I don't like locking tools. If you're going to go to the bother of actually doing the cam timing, use a degree wheel and a dial gauge. You don't do this. It's just not an accurate enough way to do it. So we'll nip the cam up there and we'll see what the timing is now. We'll see if we've undone the factory accuracy with the factory tools. Sometimes it happens. Okay, so we take the locking tool out, crank locking tool out. Okay. Put our degree wheel back in. Not sure how accurate I'm going to be. I might be 180 degrees out. Okay, that's top dead centre based on the timing mark position, and the little dot on the timing shaft is pointing straight forward at the horizontal, about 3 o'clock. So my degree wheel is in 180 degrees out. Because it was right before top dead centre was, I'll pull it out, flip it over. There's 2 pins in the end of on the end of the tool and 2 slots in the crank that line this up, and that's why it can go 180 out. Okay, so that's top dead centre vertical firing, so we'll go a bit past that. Put our piston stop in. Turn the engine back until it stops. Nice to have the starter motor out, because the starter motor's got a lot of drag in the system. Okay, that's on 13 again, to this end, and what are we on? About 15, so we're about a degree off. I like to check top dead centre a lot. I'm kind of paranoid about it, I guess you might say, when I'm doing this, but accuracy is everything. So that's 14. And that there's 14, so we'll call that top dead centre set. Pull our stop out. We'll wind our engine over again until we start to get some lift. There we go, and at 1 millimetre lift, we are on, call it 18 degrees to the outside. Before we had 15, now it's 18. So that amount of variation in the cam, when I had the tool in here locking it and the crank locked, I would say I've probably gone from the factory setting if it was pulled back on the retarded side. Now I've gone as far advanced as I can, and it's advanced at 3 degrees. That's probably where I'm going to set it anyway. So that now, if we call that 18, we'll turn this around until the valve comes, the little pointer comes around to about here again. And what we'll get is about 54. Call it 55, I think. And once again, we go back to our formula. And as you can see, the camshaft moved 3 degrees on one number and 2 on another. So we'll have probably 108.5. And that's where I would set it anyway. Is 108 realistically? I like 108 on these engines. So I'm happy to call it that. In this instance, the factory tools are pretty close, which is nice.